Hello and welcome to some examples on compound and inequalities. So the first example here is just asking us to write a compound inequality for the situation described above. So today's temperature will be above 32 degrees Fahrenheit, but not as high as 40 degrees Fahrenheit. And we realize that that's going to be then our low boundary. Okay, 32 degrees. And then our upper boundary for temperatures then is going to be upper. So all of the solutions, because it's an and compound inequality, right? Says it's going to be between those. That's how we're identifying it as an and compound inequality. We're going to go ahead and start our inequalities. In this case, we could use T as temperature, so instead of using X, let's use T as temperature. And we know to begin compound inequalities with less than signs around our solution set being defined as T. We will go ahead and write in our 32 degrees that represents our temperatures will be above 32 degrees. And if we look at just that, temperatures, our solutions are greater than 32 degrees. That works. Now we'll write in our upper boundary, which is 40 degrees. And again, let's see if that works. So it says that our solutions, our temperatures, will be less than 40 degrees, but not as high as 40 degrees. So we've matched what the writing is. So we just need to take care of the inequality and make sure it's not just a less than, that it could be a less than or equal to. It says we'll be above. Not at least, above, which means that it's not 32 degrees, it's everything above 32, but not as high as 40 degrees, meaning that it doesn't get to 40. So that is a true compound inequality for the situation. It did also ask us to graph that, so we're going to go ahead and graph both of our boundaries. We're going to find 32 degrees and make an open circle because it's not included. Additionally, same thing for 40 degrees, and then when we graph this, the solutions are above 32 but below 40, so we will get a bar in between. Okay, on our next example then, what I want you to notice is that we're going to be asked to graph and solve these inequalities here, these and compound inequalities. What I'm going to do is I'm going to solve one, number 4 first, and what you're going to see with number 4 is that it's the same thing as number 3, except for it doesn't have the word and in the middle, it's just conjoined. Compound and inequalities can be represented in both fashions. So let's solve it independently, as in each inequality, and then we'll see how it can be done together, and that we might actually prefer this method because it's a little bit more simple. It goes a little quicker. So looking at 4, it asks us to find these two separate inequalities, and we understand a compound inequality to be two inequalities. So let's solve the left side first. So we get the negative 6 is less than or equal to 3x. So if I'm solving for x to find my solution set, my first thing to do is to divide by 3. Now we're dividing by a positive 3, even though it's a negative, there is no flipping involved. Only when we divide by a negative number, not if a negative number is involved. Okay? So if we do that, negative 6 divided by 3 is negative 2, which is less than or equal to x. So our left side is done. So we're going to write the word and. We do need to preserve that. And we're going to solve the right side now. Again, similarly, you'll notice 3x is there as well. So we're going to go ahead and divide by 3 to both sides in the exact same operation. So whatever we do in the middle, we just do to both sides is what it looks like, and that'll come into play when we do number 3. All right, so looking at that, I'm going to get x then is less than 15 divided by 3 is 5. So I have my compound inequality solved that's separated by the word and. They're both a individual solution set, as in x, and then there are no other operations to do. So let's graph both of these. I'm going to graph the left side first, noting that my boundary, or my low boundary, because it's negative 2 compared to 5, my low boundary is over here at negative 2, so I'm going to identify it with a circle. I'm going to notice that it's included because of the equal sign, so I'm going to color it in. And then I'm going to interpret it. My solutions are greater than or equal to negative 2, which means that I'm graphing to the left, and that supports my understanding of compound inequalities, as it should be a barbell. All right, and looking at this one here on the right side, my solutions are, again, point comes first, so I'm going to say less than 5. All right, here's my boundary at 5. It is not included, and the solutions are less than, so you can see that when I'm done graphing, I do have a barbell. Now let's jump over here to 3 and notice that the same process, I'm going to divide by 3, I'm going to do both sides at the same time. And what I come up with is exactly the same thing, except for it's separated by the word and. So hopefully you prefer this method because it's a little bit shorter and neater to see, and that is solving and graphing using a compound inequality. Okay, on our next example, let's go ahead and do one more quick one just so we can support solving with compound inequality. We're just going to solve it as a conjoined compound inequality. Looking to solve for r here, I'm going to add 5 to both sides. And I'm going to go ahead and say that that turns to 0, leaving just an r between my inequalities, my less than signs. Negative 5 and 4 makes 1, and negative 1 and 5 makes 4. So if I were to graph that, I would find the boundary of 4. It would be included. That would be my upper boundary. I'm going to find the boundary at 1. It's going to be an open circle. And of course, my solutions are greater than 1, so I'm going to be graphing to the right. And my solutions, if I'm reading from R, are less than 4, so I'm going to be shading between. And then there's your barbell. All right, thanks for watching those. If you have some more questions, make sure you ask them in class.